Hello, everyone, and welcome to A New Hope. I am Sebastiano. I'm an Android GDE, and I work at Novora in London.
I am Eugenio Marletti. I work at Clue in Berlin and also Android GDE.
And today we're going to be talking about Flutter. So, what is Flutter? Any of you heard about it? Few hands.
How many have used
You
it?
cheaters.
No.
Friends don't count because we've been quite annoying about it. Anyone has actually used it? No? Great.
Crickets.
That's fine. That's a target audience. So what is Flutter? For the ones that don't know, and I guess for the ones that know as well, because there's a slide for it, Flutter is an SDK for building high-performance, high-fidelity apps for iOS and Android using a single code base. And now I know lights will be alarms going off like, that sounds like Cordova. It's not Cordova, otherwise I wouldn't be talking about it. Basically, Flutter is composed by several pieces. There's a rendering engine, and there is also a functional reactive framework that is built on top of it that you can or can avoid using if you want. That is kind of inspired by React Native in a way, React and React Native. It is fully open source. It is a tech preview, but it's been built by Googlers for Google. So it was initially developed under the codename of Sky, and it's been worked on for like 3 years now, after a year or two of ideas collection.
And prototypes.
Yeah, and prototypes. And the way they're working on it is kind of peculiar because this faction, let's say, this team of people inside Google is working on this framework as if they were like contractors. So basically there's internal clients in Google, which are teams that need to do some specific apps, say some content management system for internal things in Google, and they want to do an iOS and Android app, so they don't want to spend the time and the money to do two separate apps. So basically they hire the Flutter team to develop the features that they need, which means Flutter is being worked on incrementally, and while it's still in a tech preview phase, which is basically alpha, means alpha, it is already functional to the point where you can do stuff with it because it's being used already internally in Google, and I think there's a few, very few apps out there on the Play Store that are done in Flutter. So yes, it is a tech preview, but as they say, as the Flutter team says, all the hard problems have been solved, which means what is left now, aside from course corrections, is to build the feature set and get everything up to spiff so it's polished and nice. At this point in time, they don't have releases. Basically, what you do is not much more than cloning the repo. There's no releases. If they push out an update, you just get the update. Well, we'll see it later, but it's quite funny. So what does Flutter mean? I hate doing this. He likes it, so I'm going to do it. Basically, Flutter, according to the dictionary, Flutter means flapping wings quickly and lightly, like colibri might be doing, I guess, very quickly. It also means if you do hardware and electronics is rapid variation of a signal. And if you're British, then it also means it's a small bet.
Maybe that's an Easter egg.
Yeah, probably some Briton in Google decided that they wanted to take a bet. I don't know. Anyway, quiz time, and I introduced you the host of this quiz.
Thank you, thank you. So we've heard of Flutter. We've been following it for a long time, but we haven't actually used it before this talk. So we decided to build...
Last week?
Yeah. We decided to build a small sample to demonstrate what was possible. So, are you familiar with this app? You should be. It's the official Droidcon app built by amazing people in the audience, and Seb as well.
Mostly.
You're not amazing like they are.
Yeah, they're the mostly amazing. Yes. I'm mostly building the app.
Yes.
Yes.
So this app is built in Java and Kotlin, right? And it's Android
Java.
only.
Just Java,
Java.
for now. Yeah.
It is Android only for now, or is it? So this is a screen of that app running in an iPhone simulator because we decided to rebuild part of it in Flutter. As you see, it's real. It's not Photoshop in any way. This is actual code that, by the way, we are going to give you the link because it's open source at the end. And now for the second part. So these are two screenshots, real screenshots, both made on Android. Now, can you say in 10 seconds which one is made with Flutter and which one is real? Time out.
That was not 10 seconds.
I know. So the correct answer is the one on the left is made with Flutter, the one on the right is made with Android. It is surprising because they're really, really close. The main difference is the shadows, I guess, which I've been told the shadows in the end, they're going to be perfect. So they're going to be as close as possible to the material design spec. And Android itself will converge to that over time. So that means that over time, they will essentially be indistinguishable from the real thing, which is great.
The thing is, right now, if you run that code, the shadows will not be there because it's broken.
On master, it's broken, but don't worry about it. They're fixing it. Because they are transitioning into a new shadow backend, which is much faster and based on like physical rendering, whatever that means.
Physics. Woo!
Yeah. Also, if you're OCD in design, the alignment of the search icon is slightly different. In my opinion, the Flutter one is the correct one anyway, so good things. Yeah.
Yeah, there's a few pixels.
Obviously.
Yeah. Taylor knows. Just ask
Exactly.
Taylor.
All right.
So Flutter is a very interesting tech because contrary to other similar, there's not much very similar, but contrary to other multi-platform SDKs, this one is built on a very strong tech stack. So the base of it is Dart, and Dart, if you don't know, is an open source language which has been made by and for Google. Fun fact, Dart is the second most used language in Google currently and is the first one for growth internally, so they're using it a lot. It was originally done, I think, to fix JavaScript. Basically, the original idea, or at least the original pitch to the public was, we have done this new language, which is really good, and by the way, it transpiles to JavaScript, so you can run it in a browser, and you don't have to write JavaScript, which nobody really likes, or at least liked back in the day. Even though I've heard it's improved, I won't get anywhere near it. It's got a familiar syntax. It's similar to Java and C#, which I guess they're similar. But on the other hand, is a more modern language than Java.
Yeah, I want to add just, I really hated it at first, especially for the syntax, because I've been writing Kotlin lately mostly, and going back to this kind of syntax was a bit off at the beginning. But then the features of the language itself really won me over, because there's much more to it than what it looks.
Yeah, stuff like the double dot operator, which is amazing. So Dart is a dynamic language which would set, completely put me off. I wouldn't touch it because I don't like dynamic languages. But it is statically checked, and there is the so-called strong mode, which basically makes it bearable for me.
It's completely type safe if you use strong mode. Yeah.
Is pretty much you can turn it into the TypeScript of Dart. And it's got mixins, refined generics, which he likes. And there's a lot of async APIs, which means you have streams and stuff like that that you like have in Java 8 or Kotlin. So when you look into it, it is actually a quite nice language. Another really cool feature is the const construct, which basically guarantees at compile time already that whatever you're creating is going to be a constant. So there is no weird ways to create constants and trying to ensure that they're actually constants for objects like you have to do on the JVM. This one works. And then there's so-called snapshots. So what are snapshots? It's basically a mechanism that allows Dart to just serialize a stream of data and just read it back to memory as is. Basically fixes the Java way of, the JVM way of serializing stuff because everything is serializable. And in fact, they use this mechanism to, when compiling, to pre-compile stuff into a serialized stream that is then read straight to memory, so it doesn't have to be interpreted. It's just splitted, copied to memory.
And they also use it in creative ways. For example, you can cross any boundary with this. You can take any object and make it not just jump between threads or processes, but even virtual machines themselves, or you can send it over the internet or persist it. It's really nice.
And it runs on 3 backends. The one is, of course, the Dart VM, which is a dedicated virtual machine. Then, as I mentioned already, it can be transpiled to JavaScript in case you want to do web, but you don't want to be doing JavaScript, nor TypeScript. And it also compiles to ahead of time native. Wow, that was loud. So fun fact, actually, Flutter is using the latter one, of course, because on mobile you probably don't want to do anything interpreted. And fun fact number 2, the AOT compiler and native backend in Dart was actually built for Flutter, especially for that.
Yeah, and this is one of the reasons why Flutter uses Dart, because they have full control over the language. And this means they have the advantage that they can, for example, completely control garbage collection. They know when it happens, they can trigger it when they want, which is something that on the JVM would never be possible. So they can really, really optimize it in ways that are possible only with this stack.
For example, you are going to run an animation, it's going to pause garbage collection during the animation, so you don't drop frames because of garbage collection, and then it resumes after the animation is completed, which is quite nice.
Yeah, so what really is Flutter? What do you get with the package? So there's mostly layers divided into 2 main sections, which are the framework and the engine. You can use any layer from the lowest one to the top one, and generally speaking, there are mechanisms for jumping from the highest layers down in case you need to do something low level.
Without breaking everything.
Without breaking everything else, of course. So the engine, which is the lowest part, the one that you probably never use, is written in C++. And it contains the things you need to draw on the screen. So Skia for 2D graphics, and the text rendering and layout from Blink, which is the new rendering engine from Chromium. Super nice.
Skia is, in case you don't know, basically the same 2D graphics engine that Android uses.
Yeah.
The main difference is that the Skia version that Android uses is generally quite old, whereas the one that Dart uses is straight compiled from whenever you build Flutter, so it's the latest.
Exactly. So like, if you go lower than this, it's OpenGL. So you probably don't want to do that. So, okay, what this gives you is the very first layer of the framework. So the framework is written in Dart. And at the lowest level, you have Dart UI. Dart UI is like a canvas. So imagine that you wanted to write an entire app just with Dart UI. You could, first of all, it's supported. And what you would get is one big canvas. So no activities, no views, no nothing, just one canvas. And you can draw directly there and control pretty much everything you want. Now, you could do this, but what they did was build another layer on top of this, which is called the rendering layer. The rendering layer is probably the closest thing you have to Android. You have these render objects, which are the equivalent of views. So they are huge, heavy, mutable objects that hold these properties that describe how they're drawn on the screen. For example, I don't know, the color of something, etc. Whenever you want to change the way something is drawn, you just change this property, and it will be updated and redrawn. This works. This works in the same way that Android would work. But it always has one huge problem, which is you always have 2 phases for declaring your UI. You first create it. What in Android would be either programmatically creating views or inflating them from XML. And then you probably want to change the data. So you want to bind to this view and essentially manually keep the binding updated between data and what's displayed on the screen. This is why they created an extra layer, which is the good part, in our opinion. It's a widgets layer. This is inspired by React. This is the optional functional reactive framework. And we're going to see how well it works and why and what it does. On top of this, they also built other layers, which you can use, obviously, and you generally do, which are the material and Cupertino layer.
It's basically just theming. Just
pretty much.
So that you can just say, hey, this app uses material, and then everything it draws is going to be by default following the conventions and guidelines from material.
Yes, and keep in mind, even if you're using widgets, you can always jump lower and have access to a canvas or something like that, or the views, which are the rendering objects, etc. So let's talk about widgets.
There's one thing I would like to say.
Yep.
In case you want to jump lower, you can. Actually, if you've ever done any drawing in Android with the Canvas API, you're going to notice that it's basically the same thing. It's just nicer. There's a lot of pieces in the Flutter framework which are, let's say, inspired by the Android ones. So what they did is, okay, Android development started, what, 16, 17 years ago, something like that? No, 10, maybe 10, 11. Yeah, 10, 11. And the Flutter guys were like, okay, so we know what's not working in Android. Let's try not to do that and keep the good parts. So basically, that's a very interesting thing about it. You have a very familiar API, which is the Canvas API, but then it's more extensible and pluggable, and it doesn't have as many caveats as the one that we have found so far anyway.
Also, like in the words of the team that built Flutter, they didn't really invent much. They essentially took all the good parts from other stacks, Chromium, Skia, parts of Android, and extracted the really, really best parts and composed them, composed them in a way that really makes sense and is working. So the first rule of the widgets framework is that everything is a widget. So you have widgets everywhere. It creates this sort of fractal architecture where the lowest component is a widget, but then you compose it in another widget, and then you compose it with other widgets, and in the end, your entire screen is a widget, and your entire app is a widget. So you could take an existing app and embed it into another app, which is great for encapsulation, and it's great for testing stuff. So if you are developing your own screen, you can create it as an entire app, and then you can embed it in your main app. And it's a really nice way of working. It favors composition over inheritance. So all the parts that they do are extremely generic in a way, and then you create specialized widgets that compose other parts like Lego blocks, pretty much.
And when we say everything, we mean everything. Padding is a widget.
Yes. If you want to center something, you wrap it in the center widget. What on Android would be probably layout params, this is often widgets. So if you have a column or a row widget, if you want some elements to stretch for the entire remaining space, you wrap them in an expand widget?
I think so.
Something like that. So like there's way to compose stuff that are really interesting. So yes, composition over inheritance. Everything is a widget. And as we said before, these two parts of creating something and binding the data to it, they don't exist anymore. There's only one phase, which is declaration. So the way it works is that you have this function, which is your build function. And what you return from the build function is a tree of immutable object describing your UI. And you rebuild this tree every single time. Every time something changes, you're asked to rebuild the entire tree. What the system will do is that it will take the old tree and the new tree, it will diff them together and find exactly what changed, node by node. And it sounds complicated and overkill, but it's actually much, much simpler and much more effective than you would think, because they have smart ways of doing it. And because this is all abstract in the same way, they can do assertions that are otherwise not possible. So there are a lot of widgets, as we said. From the documentation, there's over, I think, 50 of them, just as an example, but that's not all of them. There's probably hundreds.
So if you look for a specific thing in the material guidelines, there is going to be a widget for that. There's obscure stuff in there that you probably would almost never use in an app, but there is a widget for it. Like the one we like the most is the stepper.
Who knows what a stepper is? That's surprising. Okay.
Well, you know, of course.
Yeah. So you say it.
So basically, a stepper, think of it as a step-by-step thing where you have a list of things you need to do in a certain order. That could be, for example, driving directions.
Yeah. Like
so
maps.
that is called a stepper. And there is a widget that does all the layout for you. You just put the items and it creates all the nice things and all whatever.
Because it's in the material design specification. And also something I love about this is that whenever you have a material design widget, when they say, please see the documentation, they actually link you to the material design spec documentation. And when you look at the widget and you look at the spec, they're essentially the same. They're really good at replicating at a pixel perfect level material design widgets. Okay, so what if you want to create your own widget, which you will do very often? It all starts with a choice. So you have essentially stateless widgets. Think everything that will not change for the lifetime of the app, or even better, if it's tied to a app-wise configuration, it might still be recreated. But if it's tied to your own state, then it's not stateless. A label will be stateless. Sorry.
For example, what you would do purely in XML without any sort of ID in Android, that is a stateless widget, basically.
Yeah, that's a good way to put it. And as opposed to that, the other parallel part is a stateful widget, which obviously holds state and will rebuild its own tree whenever the state changes. Let's see what they look like. So the stateless widget is very simple. You just extend stateless widget, and you have your build function, and from there you will return another widget. So this is how you compose anything. If you want to create something that is not a widget, there are ways to do it. You need to create an element, which is a slightly lower level binding between a widget and a render object. So like it maps between these views and these immutable descriptions of your UI. Yeah. But that's more advanced. You generally have all the pieces you need to create, I would say 80% of your UI, unless you do crazy stuff.
In the widgets framework.
In the widgets framework, yes. Yeah. So this is stateless, which is very simple to do. If you want to go stateful, there's two parts. The widget itself is super simple. You generally only need to declare what kind of state you have and create it the first time or every time you're asked to. So you create like a new empty state. And that's it.
There's one note. For those not familiar with Dart, the underscore at the beginning of something means it's private. There's no private keyword. It's just underscore means private. Yeah, and the fat arrow it means just return that. It's the same as having the brackets as I return something. So just to make it one line. And the second part is the state. So the state extends state of your widget. And the state holds all the mutable stuff that you would have in a normal mutable state. And then it has a build function which actually returns the widget, just like in the stateless one. So again, if the state is mutable, which some people might not like, this is one way of doing it. You might make the state immutable if you wanted to. It's a bit more complicated, but you could. But anyway, this works pretty well. Keep in mind, this is not for business logic, obviously. This is for presentation logic. So the kind of state that you would hold is still presentation state. Yeah. And then again, every time you change the state, you call setState, passing it a function to update the state, which will be called on the right thread, etc. And then the build function will be called again, essentially. And basically, the system goes again to check if any state has actually changed and only updates the widget whose state has changed. And it does it in a smart way. Like if you return the same kind of widget that maps, or if you return a widget that maps to the same view object, it will just update the properties of that view. If you map to a different view altogether, it will destroy that view, create a new one, et cetera, and do all the process for you, pretty much. All right. Now, this is a lot to take in, and it's weird to think how advanced things would work. For example, let's talk about animations. I love this. So good. So animations are actually pretty simple. You create a mutable widget, which what it does, it doesn't really have an internal state, but it listens to an external stream, which is the tick of the animation. And so every time the animation has a tick, you essentially say, I changed, and you recreate everything with a new state, with a new tick of the animation. So if you're fading from a completely transparent to a completely opaque widget, you would just listen to the tick of the animation and then grab the right animation value and just say, OK, this is your new opacity, and that's it. It's kind of like the callbacks that the choreographer does on Android. It's similar, but it's kind of different because the choreographer is mostly synced to the display refresh, the vsync. In this case, it's actually, you can plug your own time providers.
Yeah.
The tickers.
Yes, exactly. It also has much more interesting and advanced subtleties about animations. Like an animation has a status, for example. It can be dismissed when it's not yet started, forward when it's happening, pretty much, reverse when it's happening in reverse, or complete when it's over. And this is something I've never seen before. It has integrated support for flinging. Flinging is always the exception that breaks everything in animations, because it's not just an animated value from A to B. It also often carries a force or a speed with a fling. And that extra metadata is never taken into account when designing animations. And so it's always like you always have to jump through hoops to make it happen.
Yeah, so it's basically you do a fling, you track it, and then you pass it to the animation. And basically the animation will continue as if it was actually integral part of the fling.
Yeah, so again, fully supported. They know this happens, so you can handle it in very nice ways. And again, animations are objects. So you can compose animations a different way. You could create an animation that runs several animations in parallel or one after the other, et cetera, et cetera. So.
And then you can use, there's a very powerful concept, which is the tween, which is basically, it represents an interpolation of some sort between some sort of values. And then you can, you get in a linear value between 0 and 1, and you return whatever. And the whatever depends on the object you're interpolating. And I mean object, not value. So you can literally interpolate colors, shapes, whatever comes through your mind. If you manage to interpolate time on time, you're the time lord, I guess. But
it's super cool. They even interpolate between themes because they can interpolate every property of the theme. Yeah. So you start from one theme, which is maybe a
iOS.
Well, you can interpolate from iOS-looking system to an Android-looking system, and it's pretty much automatic if you do it through this system, which is insane. Super nice. So gestures are also very, very well thought. So in Android, they're pretty much hard-coded in the system, unless you go really low level, and you have fixed rules for disambiguation between the gestures. In Flutter, the gesture recognizer you would write becomes a first-class citizen of the gesture system. And so you can make it so that if you write a library with new gestures and someone else does the same, they can work together to find who wins. And fun fact, this place where all the gestures interact with each other to understand who wins is called the gesture arena.
May the best one win.
Yeah, I love it. So, okay, other things. How do you communicate with the rest of the system? So for example, Dart is great and everything has a support for a lot of things, networking, reading files, etc. But what if you want to show a notification? What if you want to do like read sensor data or even just do something that is not mapped yet on Dart? Or you have a library which is native for Android and native for iOS and you can't rewrite it to Dart. There is a way, it's called platform channels, and so it looks like an intent-ish. So you serialize data back and forth between Dart and the rest of the system. It's very easy to use, honestly. And it looks like writing a parcelable-ish implementation or intent with a bundle where you pass primitive data like strings, integers, etc. It's like very, very easy to do. And then once you do this, you can actually ship it as a plugin and anybody else can use it as well, which is great.
Again, the whole thing is very modular. So.
Yeah. Ooh, what else? Oh, yeah. Another great part is testing. So you can do unit test. You can do instrumentation tests where your app will be run by an extra agent, which is your laptop, generally, your computer. It runs the app as if it was a user and actually does touches, etc., and then asserts that everything is correct. But the best part is widget tests. So you can essentially unit test your UI, which means you will test all your widget implementation, creating your build functions, etc., but that's going to be run on your computer. And it's not a hack. Like, this is part of the system. So forget Espresso and things like that. You actually do real tests where you create your entire UI, although it runs in like a headless mode, because it doesn't really write to anywhere. And then you can compare that everything is correct, that all the properties are set. You can even do snapshots testing checking that the tree that is output is just the tree you wanted.
Without comparing the pixels. Just compare the widgets.
The intention of your UI, essentially. Yeah.
Because then you are agnostic of the theme, the device, the Android version, whatever. And a fun fact, the way widget tests work is the side effect of that is that you can, as Eugenio mentioned, you can build and lay out UI outside of the UI thread, and you can do that off screen. So you can basically lay out the whole screen without ever getting that to the screen. Yeah. And if you remember from earlier, we showed you the re-implementation in Flutter of the event details page from the Droidcon app. So you actually use that to define how tall the app bar is supposed to be.
Yeah. So by material design spec, the app bar should have a fixed height, like known height at least. And it wasn't known for us because the height is dependent on how tall the text is, pretty much. And so we went to the Flutter people and said, we can't do this. How do I do this? And they said, oh, it's easy. You just create an off-screen render tree and render your UI as if it was drawing to the screen, and then measure it after that. Like, okay.
And just take the height out of there. It's going to be your height. It's
fine.
Yeah,
it sounds complicated. It's actually much more simple than that, and it works super well.
Yeah, and it should be in the framework soon.
Yeah, they will actually add that as a full-fledged capability soon. So yeah. All right. So now you might be tempted to ask, so what about performance? How well does it actually run? In our tests, smooth.
Admittedly simple case, but there's no reason to think it wouldn't scale better than Android does anyway.
So compared to Android, even scrolling simple stuff generally lags at some point because of garbage collection, the system, whatever. This doesn't. I couldn't make it lag in release mode because there's two different modes. And as a fun fact, they have two threads. One is the UI thread when all the UI is drawn, etc. But then, not drawn, sorry, created, like the widgets, etc. And then they have a GPU thread, which is like the render thread in Android, where all the display lists are drawn to the GPU, etc. So they keep things in a way that it will probably never lag, not for the reason that Android lags. Yeah. So, okay, you have to understand. Oh, you wanted to
I can go on, as I've been silent for too long. There's as you have seen, there's a lot of stuff that is really interesting from the developer's perspective. I know. So the first bit is that this is something you have full control on. It's not a black box. There's no hidden APIs blocking you from doing something. I mean, there are some limits, of course, dictated by the fact that the Flutter team wants to avoid people shooting themselves in the foot. Yeah, but they're way more, the whole thing is, and we keep saying this is more, it's a more pluggable approach. So it's been thought from the get-go to be able to let people do the things they want without trying to coerce the system into things it's not meant to be doing. So you have full control over what's going on. There is no way for OEM customizations to get in and ruin your UI. There is, unless you go to the native part, like going to the, let's call it Android or iOS interop, there is no way for Samsung to break your UI unless they broke OpenGL, which you never know.
You laugh, but...
Yeah, I'm crying inside. And it's always up to date because basically what you do is you ship the framework with your application. And now that also means that there is no, I'm going to step into this function. Oh, it's a framework function. Oh, I'm stepping over what looks like a comment. Probably someone changed that in production code. So basically, you can inspect every single line of code that is being run, which is very helpful when you're trying to understand why something is crashing or not behaving as you would expect to. Yeah. Now, you would be like, I've heard of that, but like Xamarin does it, and that costs like 25 megabytes of CLR plus change and whatever. 25 megabytes might have been a completely random number. But it used to be accurate at some point in time, because I've not touched that in years. But the good news is, with Flutter is 8 megs. And considering you don't need support libraries, you don't need a lot of dependencies, pretty much for a modern app that does nothing waits anyway.
There's no method limit if you use that.
Oh yeah, also that.
By the way.
There's no
Because
method
it's
limit.
not Dex. So.
YOLO. The example that we showed you from the app, the event detail screen, is actually 9.1 megabytes, I think.
Yeah.
Something like that. So it's like 1 megabyte to implement a theme, the logic to do the parsing, because it's all doing the logic. It's not like hard-coded. Well, it is to a point, but not too much. There's no Firebase for Dart yet.
Yeah, well, no, it's actually coming pretty soon. I think IODE will announce it.
Well, there's a talk. Well, anyway.
Yeah.
So now, when you start using Flutter for the first time, you're like, am I incredibly stupid? Or is this really complicated?
No, maybe it was just us. We haven't learned something this new for a long time, so we felt kind of lost at the beginning. But
it is quite a fundamental shift in the way you do things, and I guess it would be the same if you were to try to learn React Native from without knowing JavaScript, without knowing React.
Or having a talk in a week and then,
That also is, and having to ship an app at the same time.
At the same time,
yes. So you'll be like, oh damn, a new language, a new framework, new APIs, everything is different. It seems really overwhelming. But the good thing is,
so we did it anyway, and it was great, and we love it. So it was a good being lost.
There's a very steep initial curve, but it flattens really quickly, where you just get the hang of it, and then it's quite easy. It's just a matter of looking for the methods you're looking for.
We should also mention that right now, finding information on the internet about this is not really easy, because it's brand new. But at the same time, finding help is very easy. The team that does Flutter is ecstatic about helping people, and they are the most amazing people to ask.
I was literally asking them 2 weeks ago, hey guys, how do you set the default font for stuff in the UI? Because I needed to use the font for the example thing. They were like, oh yeah, you can do this, this, and that. And I was like, I guess that's a bit complicated. I was like, yeah, it is a bit tricky. Oh, you know what, just wait 5 minutes. And they shipped the API 5 minutes later. I was like, okay, that's fine. I can deal with this. So good things and bad things. Of course, if you are on the breaking side of that change, it's not going to be great. But
just quickly, this is like the tools for Flutter feel like tools for the web, and that is meant as a compliment, because generally speaking, tools for the web are very well polished. Like if you look at the command line, you have a Flutter doctor. So you install Flutter for the first time, and then you run Flutter doctor.
You install Flutter, it means you clone the repository.
You clone the repository, yes. And then you just run this, literally without doing anything else. It will do a checklist for you of all the things that are required and how to fix them, step by step. It's insanely helpful, and it's really easy to just do it.
You don't have to have all the things. Some you do, like the first one, of course. If you don't have Flutter, you cannot use Flutter. But you can have only the Android stuff or only the iOS stuff. It's fine.
Then, of course, it comes with the IDEA plugin, which is also based on the Dart plugin. So you get everything you might expect from Android Studio or IntelliJ IDEA.
They just updated it last week, end of last week, to support IntelliJ 2017.1, which also means Android Studio 2.4, which is amazing.
Yes. You can debug code as you would expect, so step by step, etc. They even already support the new async debugging for Dart, which is amazing.
And even if it doesn't work, so even if you're stuck in a moment where they haven't updated the plugin, but you want to use the new IntelliJ version or Android Studio version, you can still do it. You can simply run Flutter from the command line in the terminal panel, and the only thing you really need to do while developing is tell it to do the code reload, which we're going to get to next.
Yes. So one of the best things about Flutter is, so you press the play button, it will build your Android app as a shell, essentially. And then every time you need to make a change, you press one of those buttons up that now are disabled, and it will reload the changes in like a second. It's like instant run, but it works.
But it's actually instant. Also, actually
Yeah,
instant.
because it's like, this is not an afterthought. This is made by design
So if you have
to run like this.
if you have ever done React Native, it's the same thing basically.
Yeah. And you even have a button to reload everything if you want to, which
Yeah.
is now rebuilding the Android app, so it's still super fast.
And if you're running from the command line, you just press R, or uppercase R if
Actually,
you want to restart.
If you want to do it from the command line, it's super easy. You have
Yeah.
Flutter run, and then you have this thing where you just press R, as you said, and it reloads everything. Super, super nice. Debug tools are also amazing. So you have two ways to run your code. The debug mode is called the slow mode, if you see the banner up in the corner. Because obviously you have all the assertions going, you have much more code to check that your code is behaving well. And so that's much more slower than a production release of this. You can, just like in Android, see the layout boundaries. The arrows are for the scrolling direction, for example, the green arrows, and the small arrows are for knowing when it's pushing the boundaries to center stuff, etc. You have an integrated analyzer for performance, for example. There's all sorts of tools, like they're really, really nice. Also, it's nice, like the experience when you get a crash. So this is, I created a fake crash, right? I declared,
Fake.
I declared a final variable without initializing the variable itself. So what happens is that you get the stack trace inside the IDE, and on the device, you find this. I almost had a heart attack the first time. This is repeating over and over the error that you had, which is also helpful because it's the real error. It's not just something happened. Yeah, and so you know something is wrong when you see this.
And again, if you don't know what's going on, you might not find it written somewhere, but just go and ask the Flutter team, and they'll help you immediately.
Yeah.
They're amazing. Whoops.
OK, so what are the limits for this? Where is it supported? On Android, API 16, and only ARM architecture for now. For now. iOS 8 onwards and 64 bits, which means iPhone 5S onwards. We don't have time to discuss anything else, but yeah, that's great. Blah, 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 Flutter, etc.
I just want to super quickly mention, there's one thing, not everything in Flutter is complete. There is very basic support for some stuff like accessibility and localization right now. But if you're doing a prototype, it's amazing. It's just super quick. Also because you can do the hot reloading, and while you're coding a layout, that's super helpful.
Yeah, and we are going to get 2 talks at Google I/O about Flutter.
It's happening.
Yes. Does that mean that we can see the future? Maybe. I don't know.
Also
yeah.
has to be mentioned, there's this new mobile operating system, operating system that Google is working on that is called Fuchsia, and Flutter is the native apps backend for that. So might not actually become anything, but it might become something, and then
like this movement going, I think it's going to go somewhere for sure. And again, to inspire confidence in this is used by Google. Like it's not made on some abstract intention of doing something. It is actually used for a real use case. We want to definitely thank the co-founders of Flutter, because they are immensely helpful, and you find them in the Gitter chat. They just reply to you directly. Super nice. We have a few links, including the links to these slides. So Flutter.io is the main website where you find all the documentation.
Including the link to the chat where those people are hanging out
Exactly. The second one is the example we created. It's open source. And the last one is these slides. So go grab them. They're not technically online yet, but grab the link.
They're going to be online when we can be bothered uploading them.
Pretty much, yes. And that is it for us. So yeah, again, we do cool stuff, and we're hiring. So if you want to join us, feel free.